61% of all violent felons in the prison system are repeat offenders. If 41 violent felons are randomly selected, find the probability that. Okay, here we're looking at the either or a violent offender or a violent felon, or they're not. So this is a binomial question. And so we're going to use the binomial function in our calculator to actually calculate these probabilities. Now you can look at a table and come up with these probabilities, and a lot of textbooks have binomial tables. But we're going to, again, we're going to use the calculator to calculate these. That we can round. There will be a little differences if you use a table, but most of these are done using a calculator, so hopefully there won't be too much of a rounding issue. So let's look at the first one. Okay, here we're talking about exactly 23 of them are repeat offenders. So that's exactly 23, no more, no less. So in my calculator, I'm going to go to second, and you see the distribution here. So this is a binomial distribution. So second vars, click on the vars, that brings up our distributions. And I'm going to hit the arrow button, and I'm going to go up, and you'll see we have two binomials. This is a binomial PDF, and here's a binomial CDF. This one is a cumulative, and this is going to be, if we want an exact probability. So for this one, if it's exactly 23, we're going to use the PDF distribution. And then the others, we're actually going to use the CDF because it's cumulative, and that's where we add the probabilities together. So I want to select for the first one, since we're looking for the probability of exactly 23, and they either are or aren't, and we were given the probability here, or actually a percentage, which is the probability of this would be 0.61. So I'm going to hit enter and for this calculator. And the way we put the N, there's going to be three things we're going to put in there. N, the probability, and then the X, or what we're trying to find, which this is the random variable 23. We're trying to find 23, or what's the probability that exactly 23 are repeat offenders. So N, and we were told there were 41 altogether selected. So 41, that's my N, that's the sample we're looking at. And then the probability is 0.61, 0.61. And we're wanting to know exactly 23. So what's the probability that we select that exactly 23 of those are repeat offenders? Okay. So we're going to hit enter, and we'll round it to 4 decimal places. So it looks like it is 0.1017 would be a probability that exactly 23 of these violent felons are repeat offenders. Okay, let's look at the second one. Now this is wanting the probability of at most 23 of them are repeat offenders, at most. So that'd be 23 or less. So we're looking at 23 or less of these 41. We want to know what's the probability that at most 23. Could be 22, could be 21, could be none are repeat offenders. So we're looking at a cumulative probability here. So again, I'm going to go back to my distribution, and I'm going to go to this time, again, we're looking at cumulative here, and we're going to use the CDF function. My N still goes in first. The probability is 61 that they are violent felons, that they are repeat offenders, that these felons are, and at most 23. So that could be 23, 22, and less. Now, this function is always less than whatever the number, the X, that random variable put in. So if I put in 20, it's looking for less than 20. This one's looking for at most 23, which means 23 or less. So I'm going to hit enter, And it looks like that probability is 0.3114 for B. Now, at least 22. Let's look at C. At least would be more than 20, 22 or more. Could be 22, 23, 24. We could go on as far as what's the probability of this. So, when we do at least or greater than, remember this is always going to find us the one less than this value. Okay. Well, this time I want to do I'm going to do 1 minus. Okay, so really I'm doing the complement of it, 1 minus, because if I put in 41.61 and 22, that's going to find me everything less than 22, which isn't what I'm looking for. Okay, so I'm going to do 1 minus the binomial. Again, it's a cumulative, and it's still a sample of 41, still the P, or the probability is 61, comma, and then remember, we're looking for at least 22. Well, this is going to be 20. We want to put 21 here. Okay, because remember, if we forget about the 1 there, if I just did the binomial CDF for 21, that's going to tell me everything less than 21. But that's not what I want. I really want the complement of that. So that's why I'm subtracting it from 1. Again, I don't want 22 because 22 is included in this one. So I'm going to put 1 less, 21, hit enter, and I get 0.86, and if we round it to 4, it looks like it's 0.8690. And then the last, this one's a little tricky because we're looking between two values here. So we want to know, we're looking between 22 and 27. So less than 27 but greater than 22. Okay, so I really would take, we want to find the cumulative probability of less than 27. So when I put it in here, so I'm just going to go back to my distribution, cumulative. Now remember what this finds us, same value here, and I'm going to put 27 because that's going to give me 27 or less, all the way down to 0. That's what this let's see, what did I put there? 27. It didn't like my parenthesis. Let's see. Oh, I didn't put a comma. Here we go. Helps if you put it in right. I was going too fast. 0.61, comma, 27, parenthesis. Okay, so there's my N, comma, P, 0.61, comma, the random of X. That's my X. So we're trying to find X is in between 22 and 27. So this is going to give me the probability of everything less than 27. Okay, but remember, I want to stop at 22. So I need to find out the probability of less than the 21. So I'm going to go back to my distribution, go to my CDF, and again, 41, comma, 0.61, comma, and I'm going to find the probability less than 21, or at most 21, because I want the probability in between 22 and 27. So I need to subtract out whatever this probability is. And it looks like it's 0.1310. So again, I'm going to take this 0.7859 minus this 0.1310, and it looks like I get 0.6549. So that's the probability that the number of repeat offenders of these 41 violent felons is if it's between 22 and 27, so we have a range here, that the probability is 0.6549. So hopefully this helps. And also your examples in your textbook of how to use the calculator to find the binomial probabilities.